Hello guys, in this video I'm going to introduce force body diagram, which is also known as free body diagram. Okay, acronyms for force body diagram would be FBD. And I'm also going to introduce a type of force called normal force in this video. Right. First of all, let's start with what is force body diagram. Force body diagram is a way of representing different types of forces acting on an object by representing the magnitude and direction of the force acting on the object, right? And it also helps us to find out what is the net force acting on the object. So for this, we're taking this example where the textbook is resting on a table, right? As I said, textbook is resting on a table. According to the Newton's second law, the net force acting on this textbook will be zero because textbook is not moving. So let's find out what are the different types of forces acting on this textbook. So obviously, the force of gravity is acting this textbook, which will always act downward, which will always try to attract this textbook or textbook downward, right? So let's find out first force of gravity that will always act from center of the mass, that will act downward. Okay, so this is force of gravity, which we can write F G for force of gravity, which is also known as weight of the object. And as you know, weight of an object is equal to mass times gravity, acceleration due to gravity, right? But you'll be surprised if the force of gravity, which is acting downward, is acting on the textbook. Why doesn't this textbook fall down, right? Obviously, the table surface is acting or canceling the gravity force in this case. So, what is that force applied by table surface which will cancel the gravity force? So the force applied by any surface on the object resting on the surface is called normal force. The force is always acting perpendicular to the surface. That's why another type of force is called normal force. That will always act in the direction opposite to the gravity in this case. And we can call that force as normal force Fn, right? As I said, the normal force is always going to be in the direction perpendicular to the surface. In this case, we have the table surface, so this is the direction of normal force. All right. So this is how we can represent different types of forces acting on the textbook. But if you actually want to draw the force body diagram, let's assume the object that we have here, in this case, is the textbook, which is a dot, right? And two different types of forces that is acting on this textbook right now are force of gravity, which is acting downward, okay, which you can write by Fg, and another force, normal force that is acting upward, okay. So this is normal force. So this is how we can draw the force body diagram of this textbook. So if you're interested in finding the magnitude, or if you want to find the force, normal force in this case, let's look at the net force acting on the textbook. As we already discussed, the textbook is at rest. That means net force acting on the textbook is going to be zero, right? What are the two different types of forces acting in this textbook? So obviously, the two different forces acting in the textbook is force of force of gravity and normal force, which is acting upward, right? So if normal force is acting upward and gravity is acting downward, one of them must be negative. So let's call normal force, which is acting upward, as positive force and gravity as negative force. So in this case, our net force is sum of normal force Fn, and gravity, I'll put Fg because it is acting downwards, so I'll put negative Fg for gravity. As we know that the net force is zero, okay? So normal force minus gravity is equal to zero, okay? So from this equation, we can say that our normal force is equals to gravity, right? So we also know that gravity force, which is weight, is equal to mass times gravity. So in this case, normal force would be same as weight of the object or mass times gravity.